But before we get started, I want to take a trip back in time to the first week of school. We're doing section 1.2, and we were finding the domain of functions algebraically. And I want to remind you of a particular problem. This was one of our assignment problems that we did, and we struggled with a little bit back then. And I made you a promise at that point. I intend to keep it today. So let's do this together. This is a good reminder. You'll be doing problems like this on our final exam, which will be here before you know it. We're finding the domain of this function algebraically. What do you see in this function that could potentially cause us problems? Got a square root and we got a fraction. So tell me about the bottom of a fraction. X minus 3, because it's in the bottom, cannot equal 0. And we know how to solve that algebraically. We just add 3 on both sides. We get x not equal to 3. And eventually, what we're going to do is we're going to graph that restriction on our number line along with any other restrictions, and we'll find where those things overlap. You guys kind of remember doing this? Right. So x minus 3 could potentially be a problem, but there's something else that could also be an issue, and that's this 4 minus x squared. Because it's inside of a radical, what must be true of 4 minus x squared? Greater than or equal to 0. And so what we did, what I saw a lot of people trying to do, and I kept telling you, no, don't do that. I saw a lot of, please don't write this down. I saw a lot of people trying to go, okay, let's bring that x squared over. Let's take a square root on both sides, plus or minus square root of 4 equals x. So, or sorry, greater than or equal to x. And the thing is, you can't solve inequalities beyond linear inequalities that way. I kept telling you, you can't do it that way. Those methods, those algebraic methods, do not work for an inequality with a degree higher than 1. And so do you guys remember how we did solve this back then? We punched it into our calculator. We punched 4 minus x squared into our calculator. I don't want you to do it just yet. We'll come back to that in a minute. I said, this is the only way we know how to do it now, but then I promised you at that time, there will come a day when I'll show you how to solve this algebraically, and that day is today. Okay, so that's our whole goal today, is solving inequalities beyond linear inequalities. So I'm going to show you how to do this algebraically. All right, so this is our first example. We're just solving this thing algebraically. So here's what we're going to do. We're going to start by factoring it. And it does factor because it's a difference of squares. That would be 2 minus x and 2 plus x. And then we're going to find some important points. The important points are going to be the zeros of one side of this thing. So zeros. What would make this first factor equal to 0? What x value would make this equal to 0? 2? What would make my second factor equal to 0? Negative 2. So my two zeros are 2 and negative 2. All right, and what we're going to do now is we're going to create what's called a sign chart. And I'm curious, once we do this, if this is looking familiar to anybody. So I'm going to create a number line, and I need to leave some space above it. So leave a couple notebook lines above it. And I'm going to put my two zeros on the number line, and I always space them out evenly. I don't worry about putting any other tick marks on there. Just space them out nice and evenly. And make sure you get them in the right order. Which one would be further to the left? The negative 2 would be further to the left. The 2 would be over here. And I'm going to make some notes on here. What's special about those two numbers? Well, those are the two numbers that make this side of the equation, this side of the equation right here, that make that side of the equation equal to 0. Those are the x values that would make this whole side of the equation equal to 0. So I'm going to put an equal 0 underneath each of those. And I'm going to go ahead and put negative infinity, infinity on here too. All right, so a sign chart starts with a number line, and then we use the zeros to chop our number line up into regions. So we're going to end up with 3 regions for this particular problem. Inside each of my regions, I'm going to make some factors. Now, this side of the equation had 2 factors. So I'm going to have 2 factors in here. And these factors don't need to be very big because, well, I'll show you why in a second. So draw me a few sets of parentheses. There should be 2 in each region. And the reason I'm doing 2 in each region is because there were 2 factors on this side of the inequality. Is this looking familiar to anyone? No, totally new. Awesome. I love when that happens. Here. Thank you. Yeah. Shut up a sec. All right, so here's the deal. Inside of each of those parentheses, I want to put a plus or a minus. All right, so first thing I'm going to do is I'm going to pick a test value in this region. Can someone give me a number between negative infinity and negative 2? X equals -7 is the test value that we picked. It can be any number you want as long as it's in that region. That certainly is. Now I want you to think about this first factor, and I want you to think about -7. If I were to put -7 into 2 minus x, what am I going to get? And actually, I don't care about the number. I just care whether it's positive or negative. It would give us +9, right? But I don't care about the 9 part of it. All I care about is that that first factor would be positive if I put -7 in there. What about the second factor? If I put -7 in for x, positive or negative? Negative. The second factor would be -2 minus 7 is definitely going to give me a negative value. Okay, you get how we're filling in those parentheses? Someone give me a number in this region between -2 and 2. Pick the easy one. 0. All right, factor by factor, let's put 0 in and see what we get, positive or negative. 2 minus 0 is positive, and 2 plus 0 is positive. All right, last region, something between 2 and infinity. I'm going with 1,000. Why not? 2 minus 1,000, is that positive or negative? Definitely negative. 2 plus 1,000, positive or negative? Positive. All right, so that's the work, that's the tedious part of this. Let's just go back and review all the stuff that we've done so far. So we had our inequality. We factored it so that we could find zeros, and we used those zeros to split up our number line. And then in each of those regions that we created, we looked at each of these factors to determine whether the factors would be positive or negative in each of those regions by picking a test value. You guys feeling okay so far? Kind of a lot of moving parts here, but we're getting it. All right. Okay, so let's translate. All we have left to do is translate and write the answer. In this region, I'm always going to have a positive factor multiplied by a negative factor. Overall, what kind of number am I going to get out of this? Positive or negative? Negative. This entire region is going to give me negative values. What about this region in the middle? It's going to always be a positive times a positive. That's a positive. And then my third region here, a negative times a positive. All of those numbers are going to be negative. Do I want the positive regions or the negative regions? We're looking for where the left side is greater than or equal to 0. I'd say those would be the positive regions, right? Are we going to include -2 and 2? Greater than or equal to 0? Yep, we're going to include -2 and 2. So my solution to this is x belongs to the set of numbers from -2 to 2, and we're going to include both of those. This is that little epsilon. It's like a C and then capital E. If a C and a capital E had a baby, they would have an epsilon. All right. Just to go back, I asked you a minute ago, do you remember how we solved this way back in September? So I told you can't do this algebraically unless you know how to do sign charts, so you're going to have to do it graphically. So what we did back in September was we said, oh, 4 minus x squared is greater than or equal to 0. Let's graph 4 minus x squared. Let's look at the graph of that. And let's figure out where is this graph greater than or equal to 0? Where is it above the x-axis? And that was between x values of -2 and 2. Do you guys remember doing it that way at the beginning of the year? There's a section in your assignment where it says to solve graphically. When it says to solve graphically, that's what you're going to do. You're going to type it into your calculator. You're going to make a rough sketch of it, and you're going to write your answer based off of that. Okay. So in the section that says solve graphically, you do not need to do a sign chart. All right. Now, the goal here today is to solve inequalities. We solved an inequality here. Now, I'm going to take this back to finish the problem that we started. The problem we started was not about solving inequality. This was just one step along the way. The problem we started was find the domain of this function algebraically. So we just solved this inequality that came from our numerator, and we got that anything from -2 to 2 worked. To answer the overall question, we would need to look at these two domain restrictions and figure out where they overlap. Where do they overlap? They overlap at -2 and at 2 and everywhere in between, and that's it, right? So the overall domain would also be -2 to 2. Now, we're not going to be finding domain for any of the problems in our assignment today. We're just going to be solving inequalities, but I wanted to take it back to something that we'd already seen. Okay, so moving forward, all we're going to do, I'm going to give you an inequality that looks like this, and we're going to solve using this method. I'm actually going to show you a different method too. So here's our next one. You guys ready? Woo, look at all those factors. This is going to be great. That just says solve it up above. I'm hiding it because I don't need you writing down all those words. If you need to write down some instructions, just write solve. Let's do a little predicting. This time around, inside of each of our regions, how many little parentheses are we going to have to deal with? 1, 2, 3, 4. We're going to have 4 sets of parentheses, but don't get too upset about that because there's going to be some shortcuts. Predict the future for me. When we finish this and we figure out which regions are positive and which regions are negative, which ones are we going to be looking to keep for our final answer? The positive ones, because we want solutions where this thing is greater than or equal to 0. Are we going to include the places where it equals 0 also? Yes, indeed. All right, let's get this started. Let's find our zeros. It was nice of them to factor this for us. We're going to have zeros at -8 and at +1 and at +2 and ooh, that one's spicy. What's that going to be? Square plus 7 equals 0. Now that's, if it's equal to 0, we can just get x by itself. Take a square root. X equals plus or minus the square root of -7. Yeah, so that would be √7i and -√7i for our last two zeros. Where are we going to graph those on our number line? Trick question. We're not. We won't. We can't. They're complex numbers. So got great news for you. These two we're going to disregard. As far as our number line and as far as our sign chart goes, we're just going to disregard these. The reason is they're not on the number line. You can't graph imaginary numbers on the number line, which is a half-truth. There's such a thing as the complex imaginary plane. We just have to expand our number line into an XY axis, but it's not XY anymore. It's real and imaginary. But we're not going to mess around with that. Calculus, yes. I think so. I believe so. It becomes hugely important in mechanical and electrical engineering, I can tell you that. Poles and zeros. All right, so let's draw our number line, and it looks like we only have 3 values to get on there, -8, 1, and 2. So it's going to be a little bit more complex than the last one we did, but not much. Make sure you leave some space above for us to do all our fun stuff. And don't worry about getting these like properly spaced out, just evenly space them and make sure you get them in the right order. The smallest number should be on the left. And the biggest number should be on the right. And actually they are in the right order. That's nice. We'll divide up our number line, -infinity and infinity. And let's go ahead and draw ourselves 4 factors in each of our regions. I had a couple students last year who drew circles instead of parentheses because they thought it was faster and looked neater. Yeah, sure. I mean, I guess technically we don't even need parentheses. We could just write pluses and minuses there. You could. That gets a little trickier with some of the shortcuts we're going to talk about, though. I like to have something to hold the place of it. So speaking of shortcuts, we can reduce the amount of work that we have to do pretty significantly sometimes if we can notice some things about the original factors in our inequalities. Are there any of these factors that have any nice properties in terms of positives and negatives that can make our job a little bit easier? What do you notice about our original factors up here? Some of you guys are going to work and doing your pluses and minuses, but you're about to miss something that's going to save you tons of time. So don't miss this, please. What do you notice about which factor are you looking at? X minus 1 squared. What's special about this factor? It's always positive, right? Because it's squared. Would you agree that this factor is going to be always positive no matter what X is? I guess it could be equal to 0, but in these regions, it's always going to be positive, right? Cool. So put a plus in here and here and here and here, and we don't have to worry about that factor anymore. Are there any other factors that would always be positive? Mm-hmm. What about this one? X squared plus 7. Can you think of any way to make that negative? We're going to square something, we're going to get a positive or 0, then we're going to add 7. So yeah, that one's always going to be positive too. So we've taken care of half of our factors without having to worry about test values. But wait, there's even more faster ways to do this. All right, now this next one, I know from experience, this does not work well for some people, but it does work well for others. So I'm going to show you, and then I'm going to go back and redo this using kind of the tried and true method with the test points. But check this out, okay? Because this could save you some time if it works for you. I want you to think about the factor x plus 8, and I want you to ask yourself the question, when is this positive and when is it negative? X plus 8. What values of x will make this factor negative? Anything less than 8 is going to make this negative. Anything less than -8 is going to make it negative, right? All right, well, -8's right here. So you're saying that this factor is going to be negative for all of my regions over in this, right? And then it's going to be positive for everything over here. Is that working for you? For some people, that's a big leap. And if you're in that category, then that's okay, because you don't have to do it that way. It really doesn't take that much longer to do it the other way. Let's try it again with x minus 2. Think about the factor x minus 2 and ask yourself the question, what values of x would make this negative? Any value of x that is less than 2? 2's right here. So you're saying that all these regions over here, this factor is going to be negative? I agree. And over here, that factor would be positive. Okay. Now, I know from experience that some people are just going to be like, I kind of get that, but I'm not feeling too good about it. So let's go back and double check the old-fashioned way. Not the old-fashioned way, the tried and true way. And I'm just checking these two, right? So Give me a number between negative infinity and negative 8. Let's go negative 100. If I plug negative 100 in here, am I going to get a positive or a negative? Negative. If I plug negative 100 in here, I'm going to get a negative. So that works. Give me a number between negative 8 and 1. How about 0? If I plug 0 in here, what am I going to get? Positive. If I plug 0 in here, what am I going to get? Negative. So that worked. Between 1 and 2, I could pick 1.5. If I plug 1.5 in here, that's positive. If I plug 1.5 in here, that would be negative. And then between 2 and infinity, I'll go with 1,000. Plug 1,000 in here, that's positive. Plug 1,000 in here, that's positive. So if you prefer to use the test values, it doesn't take that much longer. However you get there, we've got our signs now. It's time to figure out our overall values. Now, before I forget, we're equal to 0 at these 3 points, right? So let's write that down so that we don't forget. And then let's just decide our overall sign in here. So if I take a negative and a positive and a negative and a positive number and multiply them all together, what am I going to get? Overall, that is positive. There's a shortcut here. You're basically just counting up how many negatives you have, right? Even number of negatives, they would cancel each other out and turn positive. Agreed? So here, positive, positive, negative, positive. That's going to give me a negative. Same deal here. And these are all positives. That's going to be a positive region. And we said we were looking for positive regions or negative regions? Positive regions, because we're looking for places where this thing is greater than or equal to 0. So we're going to include that region and that region. And we need to make sure that we also include negative 8 and 1 and 2 as part of our solution. So let's write that out in interval notation. So x belongs to the set that includes negative infinity to negative 8 with a square bracket. 1 is going to be one of those singular solutions. It's kind of by itself, not really part of an interval. Do you remember what to put around that? Those curly braces or sideways mustaches or whatever you want to call them. And then we've also got 2 to infinity. All right, how are we feeling? This is the cookie cutter, step-by-step, always works, don't have to think too much method for doing this. Is anybody interested in a more analytic but much faster way of doing this? Yeah, let's do that. We're going to do this again, same problem, one more time. But this time we're going to have to use some concepts that we picked up along the way about polynomials, but you guys have done a great job with polynomials. So I think most of us are probably going to latch onto this analytic method. So same problem, we're just going to do this analytically instead. Now, we're still going to draw a number line. We're still going to do positives and negatives and everything, but we're not going to do all those individual little parentheses in this one. That's what's going to save us the time. All right. So I am going to start off by finding zeros again, but this time, not just zeros. We're also going to find their multiplicities. I'm going to make myself a little multiplicity in zeros chart. So 8 and 1 and 2, and then a couple of imaginary that we'll just ignore. But tell me about my multiplicities. Which of those zeros has a multiplicity other than 1? 1 does. 1 has a multiplicity of 2. The rest of them have multiplicity of 1. It is negative 8. Thank you. That could have been tragic. Thank you. And we're not going to worry about our 2 complex zeros because they're not going to show up on the number line anyways. All right, we need zeros, and then we need one other key piece of information. That other key piece of information is end behavior. Everybody's favorite. But guess what? This time we're not going to mess around with limit notation just because of time restraints. Be a great opportunity for you to practice your limit notation if you really wanted to, but we're just going to focus on the conceptual piece, not the notation. What do I need to know to find the end behavior of a polynomial? We can't find it in this form. I need it in standard form. What specifically about the standard form would I be looking at? Just that first term, right? Could you quickly figure out what the first term would be for this? It's not too tough, right? You just multiply your first term in each factor. So I do x times x times x. Why did I do this one twice? Because it's squared, right? So I'm x squared, x to the third, x to the fourth, x to the fifth, x to the sixth. So can we agree that this would be x to the sixth plus some other stuff? That would be our kind of standard form version of this. And based off of that x to the sixth, what kind of end behavior are we going to have? Like this, right? So I'm going to make a little sketch of that. It's up on the left, it's up on the right, it does some other stuff in between. Doesn't really matter. End behavior is up on the left and up on the right. Can anybody see where I'm going with this? How would zeros along with multiplicity and end behavior allow us to make a really quick sign chart? Ideas? Ah, that's key. Let's make our number line. Thank you. Let's make our number line. Let's put these numbers on here. -8, 1, and 2. And then I'm going to come back to you again. You said a minute ago, you know where it crosses and we know where it bounces. So we need to show work if we're doing it this way. And I need the work for this. Part of the work would be to write cross or bounce underneath each of these. These are going to be our x-intercepts, agreed? Where are we going to be here? Cross or bounce? Cross. And here, multiplicity 2, we're going to bounce. And here, 2, that was a single, that's going to be a cross. I want you to write cross and bounce. Yes, you could, but that's more of a graphical approach. This is more analytical. All right. Cross and bounce, that's based off of our multiplicity. How's the end behavior help us? What's my graph going to be doing over here? Is it going to be going up positive or negative? Positive. It's got to be positive because the end behavior is going to be going up forever and ever and ever. So on the far left of my graph, it's going to be positive. So in that whole region, it's going to be positive. And I need you to tell me how you knew that. We're going to make a note here. That's because of the end behavior. And we have end behavior for this region also. On the far right of this graph, it's going to be going up, 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 up forever and ever. So that whole region must be positive also because of the end behavior. And all right, now think about cross and bounce. If I'm positive here and I've got to cross the x-axis at -8, where am I going to be on the other side of -8? We're crossing from positive to a negative. So from a positive, I'm going to cross down to a negative. And then I'm going to come up and I'm going to bounce off at 1, but I'm still going to be negative because I just bounced off. I didn't cross over. And then I'm going to cross at 2, which is going to send me back to positive. So there we go. I like this way because it's faster. Isn't this faster? At least less tedious. And we would end up getting the same solution. There's an even easier way. And that is, but that's only useful to us if the instructions specifically say to do it graphically. And some of the ones in your assignment are going to say to do it graphically. In that case, you're just going to type it in your calculator, look at the graph, make yourself a quick little sign chart, and then write your solution down, okay? But if they don't say to do it graphically, I need you to do it either using a sign chart or doing it analytically like we just did. Show me some work on that. Okay, we got one more example and then we're done, folks. You're doing awesome. Hey, let's do this one. Rational function. We're totally going to finish this. Yes. The squiggly parentheses are if you have a single value or a list. So for example, if I solved an equation and I got 3 distinct solutions, say my solutions were 0, 1, and 2, I would put those in the squiggly parentheses with commas in between. As opposed to having 2 numbers, if I had like 1, 2 like this, that means that 1 is a solution and 2 is a solution, okay? If I had bracket 1, 2, that means 1's a solution, 2 is a solution, and everything also in between them is a solution. These are just at those values. This is everything in between also. Does that make sense? And you can have any number of values inside of these, including a single one like we had in the last one. All right, first step here is going to be to factor. And I'm just going to give you the factoring because let's not waste, not that it would be a waste of time, but we're short on time. You guys know how to factor, and if you don't, hopefully I've impressed upon you that it's time to learn. That's what it's going to look like after you factor it. I want you to look into the future, look into your crystal balls and think about after we get our sign chart made, are we going to be looking for positive or negative regions in our sign chart? Positive or negative regions? We're looking for where this thing is less than 0. We should be looking for negative regions in our sign chart. All right. Before we make our sign chart, though, we need to know our important values. Now, when it comes to rational functions, we need both zeros and vertical asymptotes because stuff can happen at those 2 things. So let's make a list of zeros. Those would come from our numerator. -5/2 and +4 would be my zeros. I'm going through this pretty quickly. I'm assuming that you guys are feeling okay about rational function. Is that a safe assumption? Or you'll ask me a question if not. Vertical asymptotes come from the denominator. We're going to have 1 vertical asymptote. What's it going to be? X equals 2. Yes. The zeros. Zeros of a rational function come from the factors in its numerator. So let's start building our sign chart here. Since there are 3 important values, I'm going to put 3 tick marks on here. And let's get them in the correct order. Would be first. -5/2 would be first. And 2 would be in the middle, and 4 would be over here. And I know from experience I need to mark these now, because otherwise I will forget. What is the value of this side of the inequality at -5/2? This side of the equality is equal to what? Is equal to 0 at -5/2. What is the value of this side of the inequality at an x value of 2? No. Undefined. And at 4, this is equal to 0 again, which means 2 is not going to be part of our solution at all. It can't be part of a solution for this because 2 is not part of the domain for this half of the inequality. Really quickly, is -5/2 going to be part of our solution? No, why not? It's less than 0. We're looking for values that are less than 0. -5/2 makes it equal to 0, but that's not less than 0. Okay, so we'll keep that in mind. So let's make our regions here. we'll do the old tried and true method for this first one. Looks like we got 3 factors. So we'll get it set up and then we'll come back and put our pluses and minuses in. And before we start picking test values and plugging them in, let's see if there's any of our factors that are special, that are always going to be one thing or the other. I see a special factor. Do you see a special factor? This one's being squared. Isn't that always going to be positive? Except where it's equal to 0. We've already got that taken care of here. So yeah, that factor is always going to be positive because it's squared, at least inside of those regions. These ones could change though, so let's pick some test values and see what we get for them. So go ahead and pick some test values in your regions. I like to, when I do these far ones, I like to pick really big numbers like -1,000. Because it makes it pretty easy to see. 2 times -1,000 plus 5, that's going to be pretty close to -2,000, right? It's going to be negative for sure. And -1,000 minus 4 is definitely going to be negative. Between -5/2 and 2, I think I'd probably pick 0 in here because we can. Put a 0 in here, we'll get +5. And 0 in here will get us -4. Between 2 and 4, the obvious answer is pi. So that would be positive and that would be negative. Why not? And then between 4 and infinity, I don't know, 1,000,000. Well, we can't substitute infinity in there, I think. Sorry. But we could pick a really big number. 9,999,999.99. I think they're going to both be positive. All right. So what's that going to give us? Negative times a negative divided by a positive is positive. And positive times a negative divided by a positive is going to be negative. Same thing. And all positives is going to give us positives. And we wanted, what did we want? We wanted less than 0. So we want the negative regions, which would be this one here and this one here. And yeah, that's it. We got to be careful that we don't include 2 and we don't include the endpoints. So -5/2 to 2 and 2 to 4. That's a 2. Let's not forget our little x epsilon out in the front just to make it look fancy. The epsilon is like, it's kind of what that was. I said 2 and I don't know. I wrote a U and then I tried to make it into a 2, but it just wasn't really working out. So we erased it and started from scratch. This epsilon is just kind of like an equals, except it's like, it's not equal to, you can only be equal to values. You can't be equal to sets. So this region is from -5/2 to 2, right? We're not including the 2 because I got a parenthesis around it. We're including the negative region because our original inequality was less than 0. Yeah. Yeah. Because of the less than 0, we wanted the negative regions, all of the negative regions. You can do this analytically too. Can we talk through that really quickly? This one, I'm just going to go ahead and draw my number line and do my work for it. So the initial work would be the same. We'd still be finding our x-intercepts and our vertical asymptotes, which would be in the same place. And again, I'm going to write equals 0, undefined, and equals 0. I find if I don't go through and write this undefined thing, I end up including it when I should not. That's why I do that, and I try and do it early in the problem so I don't forget. That's been a common mistake for me anyways. So let's talk about our intercepts and crossing and bouncing. These are both intercepts here. Are we crossing or bouncing at these intercepts? They're both multiplicity 1, right? So we're going to be crossing at both of those. And then I want you to tell me about this vertical asymptote at x equals 2. Which dance is it doing? Is it doing the opposite direction dance or the same direction dance? So we're going to be going the same direction on both sides here. So I know if this is minus, then this is going to be minus. If this is plus, this is also going to be plus. And then the last thing we would need would be our end behavior. Now, if you go back to our original polynomial, I got to scroll back up here. What type of end behavior asymptote would this thing have? Horizontal asymptote or one of those slanted or quadratic ones, first of all? It's balanced. Horizontal asymptote, is it y equals 0 or are we doing lead coefficient divided by lead coefficient? So it'd be y equals 2. So our end behavior asymptote is y equals 2. So for my end behavior here, it's y equals 2. It's going to flatten out at y equals 2 at the end behavior. So is this positive or negative in this region? 2 is positive, right? So it's got to be positive here. And the end behavior here is also y equals 2, which is also positive. And I know I got a cross, which would make this negative. And then I got to go in the same direction. So it's going to stay negative. And then I got a cross, and that gets me back to a positive. And there we go. So I'll leave it up to you. When the instructions say to make a sign chart, I want to see a number line with pluses and minuses. Whether you mark your end behavior and cross, bounce, same direction, opposite directions, or if you want to go back and do the pluses and minuses, that's entirely up to you. The assignment's up there. I also put the review assignment for the chapter test up. That'll be due on test day, but you're not going to have much time next week during class to work on that.